Good to see you guys.
All right, I will start, and I will not turn on my camera. I apologize for that. Something strange happens, and I just have a new laptop, so that's probably why that's happening. But I'm at least sharing my screen. In the meantime, there will be some more people coming in. Welcome all to this. It's the second safari of this year. The first one was around commissioning. So Paul Turner gave that presentation. Thanks again, Paul. That was great. That was a great one. For today, I think we have another great topic to discuss, where we have Saber Belghith from, and I need to say it right, because I always say KonnectXD, but that's actually the name of your platform, KonnectXD. But your company is TwinTech, I think.
That's right.
Welcome, Saber. We are delighted that you're willing to spend your time. You are in the Far East, so it's late for you in the evening already. Thanks for taking that time. Very, very much appreciated. I will let you do your introduction a little bit later by yourself. Yeah, I think that's great. The information was shared to this group of people. But let's have a little bit of background about USPI mission and vision. Yeah, we are USPI NL. We are in principle a Dutch organization, but in the light of all the globalization of the process industry, we became more and more international. And we are a foundation that is really focusing on developing, maintaining, and promoting the use of international standards, and particularly around the data interoperability. Is it me that is hearing that strange noise?
I don't know what it is.
Okay, so that is really in our mission. We do that for more than 25 years right now, and we have done some very good work. One of the things that we are doing, besides a number of projects, which you can read on the right-hand side, and I won't go through them all, but one of our flagship projects is the Facility Lifecycle 3D modeling specification. And actually, I can't actually recall how we connected initially, Saber, but I think I saw something about what you were doing. You posted something probably on LinkedIn, which I picked up, and I thought I want to share this with the wider community, where we in the FL3DMS we are working with other standardization bodies under MOUs. Memoranda of Understanding. One of them is CII, the Constructor Institute, that has developed this AWP, Advanced Work Packaging standard, and we think that's a good thing. But you told me that there might be a different view on that as well, and that you are really trying to find ways to improve the ways of working in construction, particularly. So I did not want to withhold that. I think it's very good to learn from other perspectives. So I'm really eager to hear the philosophy around this and why it's different than maybe AWP and where the overlaps are. And of course, we're always interested to learn from others how they implement these kind of things. So this was really related to how to deal with 3D data, and but I think your story is way bigger than only 3D. So I'm really keen to hear that from you. Like I said, this is the second one. The second safari this year. The first safari was about commissioning, which Paul Turner did in February. So today it's time for construction work management. Saber will do that, but before I do that, just a little bit of background of the members or of USPI, and this is really where you see how it fits together. This is not just a couple of people that have a warm heart for standardization or something like that. No, there is a clear drive behind all this. There are owner operators that have a need to have projects delivered in the right quality, according to the right standards and schedule and cost, of course, and then be able to operate them efficiently. And all these people that are involved in here, you see some operators here, but you also see the EPCs who are clearly a key player in delivering that. But also you see some other companies like software vendors and consultants that help to deliver all these parties in this supply chain to do what is needed. So this is really from a business perspective, we are trying to achieve this data interoperability. Having said all this, Saber, the floor is yours.
All right, thank you so much, Hugo. It is actually funny that the first Safari was commissioning and the second Safari is construction. You know, we're going backward with the end in mind.
Exactly.
So the next one will be procurement.
Maybe.
All right, thank you, everyone. Good day. I'm in Kuala Lumpur, so it's quite late here. Thank you, Paul. Let me share my screen. I take it over.
Sure.
I'll take it over. Taking over. Let me share this. And give me a second. Share my screen. I think wrong screen. Share this screen. Yeah. Are you guys able to see my first page?
Yeah, I see it.
All right. Excellent. Let me see. Perfect. So, hello, everyone. I'm Saber Belghith. I'm the founder and CEO of KonnectXD. Today, I want to take you on a journey, not into a software. So I'll put my software hat away for a second. And I'm going to use the experience I have, the different interviews and discussions, and this industry expertise that I have collected over the years to show you the real world of the construction. And we're going to talk about chaos. We're going to talk about risk. We're going to talk also about opportunity that exists when we rethink how capital projects are executed. So the title here could just as well be, what if we started from the field and worked our way back? So here's our flow for today. We'll begin with a safety moment, not because it's mandatory in construction, but I think it's a good lens on to how we should think about planning and risks. Often studies are made where safety is number one priority for steering committees, leadership boards. Any injury, any incident on site is a real reputation impact to companies and brands. And we know how brands are important. So from there, we'll zoom out to give you the big picture, showing you the challenges. It is important that we go deeper and unpack the problems that we currently face in execution of projects. So as construction is part of a bigger scheme of things, the execution model is failing. That's my opinion. That's also stats. Many projects are behind schedule, cost overrun, and so on and so forth. We'll explore how the future could look like, data-driven, simulation-enabled, and AI-assisted. We can't do any more presentation without talking about AI. So I actually added that yesterday, and I thought, how could we do a presentation with that AI nowadays. So finally, we'll land into a call to action, and I'll call out a few things and see how our industry can respond with group like USPI and initiatives like the FL3DMS that I would be very pleased to join. So a bit of safety, walking on the edge. This is how I titled this slide. It's not just a safety metaphor. It's a project reality. You've got planning, you've got known processes, common legacy tools. It's all made up of the best team for the project, and yet you're always one misstep away from delay, injury, and worse. So here's a thought. What if safety and safety training in occurrence could be adapted to construction progress? So very real time. What if we use virtual environments, sort of game-like simulations, and rehearsal? So rehearsal safety through the actual construction real-time progress. So it's not just to train, but it's to plan, right? And I put this learning pyramid. Well, I actually made it as a circle card. And practicing by doing is seen as 75% retention, active retention of training of anything. So training of safety could be one of the actors for this. So because really the truth is that safety is not just check boxes like BBS programs, behavior-based safety programs, or just safety records and forms that we have to fill in on site. It's more than that. It's how could we have a system of anticipation? There are many research papers, often by MIT or Berkeley, that shows that game-like platform could bring together the project under construction and safety best practices with lesson learned and all the feedbacks and scenarios, and it could be built into the gameplay, and all the engineers, the foremen, the scaffolding engineers, whoever can join in and practice by doing. We got to look at the big picture. I think it's always nice to macro view it and then deep dive, see where I'm coming from and where I want to go. There is a very big global energy demand. I mean, I don't have the values exactly, but the values are increasingly important. So the growth rate over years is increasing itself. It's not a linear growth; it's an exponential growth, and we're really witnessing unprecedented demand for energy. Infrastructure is expanding. We've seen, mega project in Saudi Arabia, global transportation systems, data centers, AI data centers, even bigger demand, and the regular cloud and digital services. So this all need energy, and so with the energy production not being free, it has consequences. So looking it up on the International Energy Agency, we see that oil and gas operations alone account for 15% of energy-related emissions of CO2. The construction sector, and I wasn't able to split oil and gas and to just look at oil and gas as its own, but I found another graph that you see on the screen. 37% of building and construction, all construction together, represent the global CO2 emission. And this 37 CAGR, so it's a compound average growth rate over 10 years, I think. So 37 average every year. Oil and gas is in red and green, red plus green, and coal is in blue. So, I mean, everyone can see it's not a linear curve, it's exponential. I don't know, I hope there is a bubble. I know the graphic on the left is a little bit chaotic, but we have a role to play, and I think we're in trouble. Like it's really quite important that as the demand rises, we're actually seeing negative net digital innovation in construction. So over years, there is such a limited amount of innovation in construction as in, yard, fabrication, erection, work. We fall behind year after year. The other industries have leaped forward with automation, AI, integrated data. Construction remains completely fragmented. The tool adoption doesn't always lead to improved outcomes. We're adding tools, but not always value. So this lack of digital maturity has ripple effects. It implies contracts and claims battles. It slows decision-making. It weakens alignments. With every partner working from different tools and different truths, even small delays or misalignments become costly disruptors. So as we look ahead of with the next 20 years, I've seen from one of the studies that we expect 60 to 90 new FPSOs to be built. And with 90 FPSOs to be built, we are going to respond to the demand of energy. But with the net innovation of our current industry, we are not going to make it better. It's just going to get worse, and projects are getting bigger. If you've seen Yellowtail, One Guyana project is a mastodon of FPSO, about 300 meters FPSO. So it's mega projects. I've seen companies, we all operate as companies, and let's be real. Companies have P&Ls, have shareholders, has investors, and we have financial pressures. The margins are thinner and thinner, and everyone is looking at cost-saving approaches. So you see JVs between companies, EPCs. You even see JVs between EPCs and real Cs, the construction yards over Asia. And we also see a lot of bizarre choice of moving engineering centers to Far East Asia, or Far East Asia becoming EPCs themselves, as historically they are construction only. So the impact are going to be multiple, various facets of it. Projects are more and more constrained. It's fast track. Everything is pushed forward to, pushing drawings and issuing revisions anyways. And then you'll have the claim game down the line. So yeah, not so good looking. Next slide. And I wanted to tell you a bit about the construction phase and what does it really include? We often presented with this Gantt chart, right? Everyone have seen these Gantt charts. It applies to onshore, offshore. It applies to FPSO, modularized project, onshore, in situ type of construction. And I'm always concerned with this kind of graph because they don't depict the actual reality. And I've tried to depict it. I spent time preparing this presentation. It's the first time I tried to put this together. And I want to tell you that the FEED phase, as we know it, right? We work around the FEL concept, methodologies, strategy framework, front-end loading, and our FEED and design phases, build the constraints, build the quantities, build the strategies. Yet, we do not see a lot of construction initiatives within these efforts. So in my past, I worked for Technip. I was part of an amazing group called the Construction Method Center. It was a corporate group reinventing, pulling the lesson learned of, hundreds of projects, years of feedbacks. And we've developed so much, more construction engineering and helping out project execution plan. It was an amazing time. That really built onto what I know today, what I've done, and how I've built KonnectXD. So with construction department being more involved in FEED phases, early on in design phases through preliminary construction studies, could be heavy lifting, could be scaffolding studies, constructability programs, reviewing construction schedule. We speak about construction schedule in a bit, and helping out making sure construction man hours are adequate, to not say accurate, adequate. So it is a real problem because we estimate the project based on outdated indices. The index, the Excel files, the historical data is either outdated, either poorly managed in Excel. And we build this preliminary plan that actually becomes the plan. These become schedules and cost estimate, and we assume that it's going to be a clean handover between FEED and EPC detail or EPC execution. So a bit about softwares, not mine, others, the engineering one. I know we may have some Aviva guys in here. Aviva is great. I have no problem with Aviva, actually. It's a constraint. Coming back to P&L and companies, I mean, you're looking at being lean. I mean, you have a bunch of smart people in these companies, and they try their best to standardize, to lean produce whatever they have to do. Although it's in silo, it's in core softwares, but it's a common group effort, people effort to put together a project. But here's the catch: owners and operators. So back to you guys. You guys have requirements, and it's all understandable too. You do have a decision to make for all your assets. You got to be a Aviva, let's say, how to say, owned kind of systems for your digital continuity, for your standardization of operation, and you got to be either choosing Aviva or Hexagon Smart Plant suite of product. So you got to make a choice. I don't think I came across a client owners that are using both. It could be legacy one, and then they have taken the decision to only use one. But down the line, EPCs must use both and administrate both and build all their processes either upon each or converted and transformed so that their business processes remain relevant and efficient and transformable, flexible enough to improve it, because it's never good on the first batch, isn't it? So, needless to say, it's not clear, and there's a lot of noise at the beginning of the project at the right triangle. So I have a tentative slide of how it's really being done. So you used to see the EPC Gantt chart. I've made the Gantt chart of whatever is going on. And so line by line, engineering has increased by a lot, and it's not a joke. I wish I had done this. I wanted to do this by man hours, and looking at the bars like this doesn't show the amount of man hours spent in construction is a lot more. Just that the thin bar is a lot. So I had to split it into what it is actually. So the issue is engineering goes on for a long time. Procurement start pretty much when, long lead items very early, and then it happens for a long time until we actually get 90% right. And I can tell you, we have quantities of engineering revision after it's IFC, and it's not looking too good after 90% either. So we have a sort of a broken model, and that's probably my next slides. But I really want you guys to focus on this part. Construction is just not construction. Construction is in charge of detail design. Construction actually take the 3D model of engineering and make it into a fabricatable, an erectable, a construction grade 3D model with actual steel structure, actual welds and spools, and things get fabricatable. Although they wish they can have more information earlier, they're unable to plan production of their fabrication. So this phase of manufacturing is often underestimated, I would say. It's an important link between procurement, detail, and installation. It is a very important workstation, and I'll speak about workstation a bit later. I have to be mindful of the time. I'll spend the whole day talking to you guys. So 20 minutes. I have about 25 more minutes to go. I think I'm going to accelerate a bit. So,
Yes.
yeah. So what I've seen is that construction is a great mindset. Construction would do things that is not necessarily on paper, but they want to get ready. They want to make sure they have planned enough resources. They have understood the scope of work so that they can, use a maximum of their fab shop and painting shop and scaffolding. Because remember, construction yard do not belong to EPCs. Construction yard do not belong to owners and operators. Construction yards can do 2, 3, 4 clients at a time. Therefore, they have a workstation and a manufacturing issue of delivering to certain project. So we'll speak more about them later. And manufacturing will deliver to installation. And I love to split construction into pre-commissioning and commissioning, and really pointing out that these guys do not just show up here. I mean, these bars are counterintuitive. They don't start working here. They actually want to work a lot earlier. They need PNIDs. They need to prepare loop checks. They need to prepare understanding of their systems. They need to do a lot of work. And this is what Paul Turner presented a few weeks ago, and I invite you guys to go watch his presentation. I think can easily find it on LinkedIn. It was great, Paul. And lastly, I wanna bring to your attention a bit of something between the feed phase, where we develop 3D models, by the way. It is more common, I hope. And I don't think it's just going to go slower about that. It's just going to be more and more automated and better information, therefore better estimates, maybe better schedules, better understanding of the scope of work. And this is a 90% EPC model review. That's why I put it right here. And I have the next slide to explain a few about it. So I put together a 100% feed and a 90% model review. These pictures are 10 years old. I took them from an old presentation. And I call this Where's Wally? I think in French is Où est Charlie? For those that would not understand this expression. and I had the data back in the day, but I mean, look at it. This is 100% feed. This is 90% EPC model review, although this was 18 months later. And if I come back to this, I remind you that construction want to know as much as they can, although they can't get any information, or not much, unless there's a certain maturity of the engineering. So I also remind you this curve that everyone knows is the impact and the influence you can have on design and the cost impact when changing stuff. And so I put that red triangle and that line to show that this is the award of the EPC project. Therefore, FEL3 starts here, and then anything you kind of do is a really wide impact. And again, everything changes because everything is in parallel. As you issue ISO, IFC, you have to expect 5 other revisions to come. Obviously, the devil is in data. It depends what changes. But because it's an analog process, we got to look at it from a different angle. So I also put down this slide that is about putting together the FEL stages that we know with the BIM stages that we probably not all know in here. It's the building information modeling, a lot of you may know, and the modeling, the BIM with their modeling levels. So they have different, ways of talking about it. They have rebar stages, but they all kind of match. And BIM with levels and LODs match in this area. And our FEL kind of match also with a little bit of overlap and differences in some of the places. But I want to highlight this area. The area of concern right now, the EPC phase, where we have a 30%, 60%, 90% model review. And when things are issued for construction about here, for us, they have already an advanced modeling that is probably a 90% LOD 400. This is fabricatable. This is installable level of development. What I found fascinating is that when BIM showed up a few years ago, about 30 years ago, from Germans, a first paper written in 1979 by Germans. I think it was titled Construction Database-Driven Construction, something like that. Something that says, damn it, we need to do construction differently. And Autodesk and the whole mega companies were able to leverage this research paper and develop softwares and processes with the industry standards. There's other group like USPI that is building smart, and other group that are very a bit more advanced than us. It's a bit different, but what's quite interesting is that BIM brought with it strong technical methodologies. It brought with it guideline. It brought with it need for product catalog libraries into the 3D softwares, and a whole framework, obviously, of working between disciplines. And you see VDC, virtual design and construction groups, in the middle. That is an augmentation of planning. And similarly, we have AWP groups from frameworks, and a bit of difference though is architects in the BIM world. They have choices of creativity. They can design things that is out of the box. In our industry, we rely on process engineering, strong methodologies, material classes, piping class, libraries, product libraries, and so on and so forth, catalogs that really helps fundamentally the capabilities for shareable data and unified data. Unfortunately, the engineering do not build the 3D model for a consumer that would be construction. They build the 3D model for themselves. And most recently, thanks to CFOS and some other initiatives required by owners and operators, making it an asset that they can actually use for operation and maintenance. And here's another problem that we encounter in 2025. I came across a real owner-operator request in a tender, and they're asking for an enterprise information management tool. This is a big box. I love how it doesn't have a name, really. It doesn't have an image compared to everything else. It is something that no one knows how it looks like, what it is. It looks like something that serves like single source of truth. It looks like it serves as control over the data, the things that gonna change, automation with the this icon, the automatic icon. It looks like it's a guarantee for quality or better quality, and the availability of this data, being able to have a repository where data can be consulted. But it really is to show that although there's a lot of problems with this from a software architecture point of view, but it is a good effort. It is clearly not something nice to have anymore. This is expected, so owners are really pushing for it. EPCs are adapting. EPCs are using a new set of tools. They are amazing tools, like Viva Engineering and some other tools that could respond to some of these aspects. Yeah, it is the real truth. So my next slide is jumping into the future. It's a future where we start shifting gears, where data is not just a byproduct, is something that we trace. We want it to be data for execution ready model. So it's not just about adding dashboards. We see too often our companies building Power BI dashboards over poor data, or being not able to replicate or go deeper or higher or connect it to 3D. It is not just dashboards, plain and simple. It is really about rethinking how we connect the physical and the functional tags. So that's another important word for us. Tags where, we could assign work to tags. We could track the changes on tags. We could move towards real production readiness. So if you think of an FPSO, a bit of sizing of what we're talking about. So with KonnectXD, we've done about 7 or 8 FPSOs, not small ones, big boys. And those have 150 systems, up to 300 sometimes, 5,000 lines, kilometers of lines, obviously, 15,000 isometric, 50,000 spools, 150,000 wells. It's kind of big numbers, but still something that is manageable. It's not called big data. The scale is quite brutal for the size of the project if you compare it to something else. I think one of the biggest projects on shore was about 20,000 something isometrics back in the day. But that information is actually unreliable, in fact, because piping isometric is a byproduct for exporting drawings, and I have something against that. So I think lines, number of equipments, number of PNIDs, that still remains, and spools is very physical. So spools are the little pieces that we have to put together. They go from 2 kilo to 2,000 kilos. And it's very important to see that it is very easy to kind of lose control, and lose control fast, especially when you are a slave to engineering and procurement groups. Not in a negative manner, in fact, but you're waiting. And as you're waiting, you are unable to scope out, hire people, keep people. And so, okay. So now let's imagine if every activity could be tracked by tag, if change could be captured in real time. So changes from the engineering, changes happening on the construction site. And if we could clearly identify work front. So I like to categorize work front into 3 main categories. Work front that's not available, but is planned. Work front that is available and planned. That's like a winner. And available work front, but that's not planned. And we got to think about what are we going to do with it. Is it going to stay in laydown and perish, or is it going to be squeezed into assembly line and fabrication line and installation? So it's all about moving to a look ahead production work front, and this is about understanding the time and duration that every single tag across every single activities will last, so that we can plan out weeks and months in advance. Remember, construction is not an hourly scale type of efforts, is not even daily. You know, you have almost no leverage on a daily basis. You got to plan ahead. It's at least 4 weeks ahead to be able to move a needle. So that's what our model is looking to solve. We're trying to hack these criteria, maintaining traceability between the functional world and the physical world, because it is lost in the music. It is sad, but everything is analog. Therefore, you can't even trust line list and equipment list anymore. These are Excel documents. You have a hard time trusting the first IFC revision of a document. So we're trying to build, better software, which is going to help construction, eventually more people, but through a workstation mindset. So I gotta jump to technology, but actually I wanna show you a bit of what's written right there on the right, on the diagrams, on the pictures. Let's start by the top. Reconnecting what the system, what are the ISOs, what are the spools, and having curated data is not anymore a nice to have. Having the painting surface area, knowing the quantity of square meters of painting for isometrics, or the volume in cubic meter for later on testing and cleaning, the total weight and all this data curated. It is also, the name of the game is also quality. On this picture is a representation of the physical world and the functional world not being able to connect with our current tools. Our tools gives us piping within CAD software and detailed spooling in another 2D diagramming software, and steel structure is actually done in another CAD software, and the reconciliation of steel structure supporting piping is not done at all in our original source CAD software because it's too heavy, it's too complicated. The STP file is not intelligent enough. The graphics, the triangles, the geometries, the B-reps of the steel structure is not getting imported properly into CAD software without giving names. And so this is where Connect3D come into picture. Connect3D in this picture have connected, Connect3D has connected this pipe with this ancillary pipe support, with this steel structure pipe support, with this steel structure beam. And today, if you were looking at how we process data without KonnectXD, you would not have this information at all. Although you could open tons of drawings and making sure you have the right revision. On this picture, as a client of ours required us, because steel structure and the engineering CAD model are disconnected without Connect3D, they have asked us to find discrepancies. So some people would think of clash management for this, clash checking, clash detectives, whatever the name. We've invented physical relationship checking. We can tell immediately through our processing that this piece is connected to this piece, that this piece is connected to this piece. And we can also find all the discrepancies on the right side you find pipe support that is not connected to the assembly beam that is below it. So instead of doing clash checking, we're looking at void checking. So I got to jump a bit about tech. So what's the foundation of that model? Is trust. And that trust is built on data you can believe in. You ingest it properly, you build robust pipelines, you clean it, you analyze it, and only then can you start to simulate and forecast accurately. You can actually do a lot of things, but just forecasting. Right now, we simulate based on assumptions. But what if we simulate it based on actual project conditions and by tag or by test pack or by system readiness? That's how we move from firefighting to foresights. This is how KonnectXD is built. So in essence, this is building relationship graphs, tons of them, business-minded, and then being able to go through progress, quality, and completion. For trust, let's stay focused on trust for a second. We all know what it's like to chase down the latest revision or realize too late that a spool drawing was outdated, although we fabricated the spool. Without quality control and structured ingestion, your beautiful software stack is just a house of cards. So we start with data pipelines. We design for engineering data, construction tracking, material progress, and then we enforce quality gates. Are the tags consistent? Are the relationships intact? Is the hierarchy valid? The 3D model hierarchy, is it valid? Is it comprehensive? Is it accurate? Is it complete? Is the metadata of PNID number matching a tagging convention? There is so many questions. Our projects are complicated, but yet we do not have the right set of tools to handle them from a data quality standpoint. So we've built dashboards, pipelines that you actually can build and precise the workflow, clean recipe, split information, join databases, and run some automated processes. And just for the sake of it, there is no AI here yet. So how many of us really had the chance to look at a project over time, every day, and look at the material takeoff quantity from the 3D model and any other sources, in fact, and seeing the amount of isometric going up from model review 0%, model progress 0% to 30% to 60%. Has anybody been able to actually compare to projects? That's the question we're trying to answer. And our next slide is it's quite important, is maybe the most important slide of my presentation. Maybe not, in fact. There are some other interesting one. So, but it's a big one. I have tons of conversations with leaders in the industry, and what we came to a common understanding is we need to manage change. We are not able to manage change. We have too many people looking at it. We have no data about it. We have emails, we have Excel data sheets, we have submittals and transmittals and document management control, but the projects really change every day. How much can you actually put on someone to track all those changes? So we often treat changes as exception, but it's actually the norm. Changes is all the time. So instead, we would like to think that change needs to be captured at the data layer. When a tag moves, so it's routing, let's take a piping isometric, a line, and something moved, a metadata changed. Something moved, we can tell, by the way. We can tell that something changed routing. We don't need a designer to put the information there, in fact. What if the spec changes? Something got updated about equipment, vendor drawings came in. How could this ripple through the model? Not the 3D model this time, the data model. And we should be actually able to track that ripple effect across everything, not only disciplines and system. What's the impact on activities? What's the impact on the current progress? Wherever it is, it's just an activity. So this is not just about traceability. It's about control of the scope for everyone, visibility, by the way, the work and the time. Too often we overtime everyone on the team, especially when it's report time. And let alone construct, I think I have the ability to use a laser pointer. I think the whole time I should have done that. It's funny, let me use that word and we'll discuss and agree later. We reconnect the PNIDs together. We connect functions together to the functions of a PNID, to the actual physical life of that piece of the PNID, part of this system, and knowing what's going on. So a system like this is also built for simulation. Once you've built that trust, quality control, data analysis, you're able to unlock simulation capabilities. This is not science fiction. You can simulate system completion readiness. You can simulate spool delivery timelines. You can even test package. You can even check the test package maturity. Imagine being able to say this test can't happen because 2 upstream wells are still pending, and they are delayed because the manpower are on another system. That's where simulation becomes a command center control tool. It's not about pretty charts, it's about operational decision made in real time with confidence. We are very familiar with S-curves. We are less familiar with being able to view in the future what could be available and what will not be available. So I want to speak a bit about competitive advantage through a chart. So the S-curve, the typical S-curve. So it's really about moving from theory to strategy. So let's just face it, it's just about being neat and tidy. We wouldn't be having this conversation. This is a competitive play. Yards compete for the same projects, EPCs compete for the same project, and at the end of the day, we are looking at profit margin, optimization work, and we go from a project to another project with no step back to be able to effectively change something that wasn't effective, if you see what I mean. So the companies that master digital continuity aren't just more efficient, they win more projects, they deliver faster, they reduce their profile risk, and that's really the edge. The advantage is not just about the software, it's about the mindset. It's treating the data like it's a critical asset, not a byproduct. So this is the other view of it when you have simulation capabilities. So what do we get here? So we start by reorganizing how data flows from engineering all the way to commissioning. We track every pieces, every tag of the puzzle. Materials, pools, systems. I've been focusing on piping is most of the work, but you can imagine it's a disaster on other discipline, in fact. And we integrate, we connect things together, not in isolation, but across disciplines. Things connect to each other. A pipe support of another discipline, well, of the structure discipline, is really connected to a spool. And you won't be able to erect the spool unless that pipe support is installed. So once you've got this connected digital thread, you can do things others can't. Predict delays, simulate alternatives, and make faster decisions. A construction yard would have about 2-4 projects at a time, although they have only one production line for fabrication, only one fab shop, right? Well, they have strategies to subcontract to other fab shops around their neighborhood, but they would have to give, accuracy of scope of work to this other yard. There will be a subcontracting strategy with claims and issues and delays. So the problem is just pushed to another yard, or EPCs, splitting modules across several yards, although themselves with procurement, they have to take a decision, which yard do we furnish this material, isn't it? So fabrication is one line, and you're limited in capacity. You don't have an unlimited number of workers or kilometers of fabrication line. It's not BYD, it's more of a Peugeot kind of thing. So warehousing are limited, laydown are restricted by the space, and fabrication and resources are limited, just like cranes and scaffoldings and people. So that's really that optimization and simulation edge that allows you to be a difference between reactive and being ready. So I want to have a detour to AWP after everything said, but it's really worth discussing it. AWP is a really strong business framework, but it just can't stand alone. It usually gets introduced at FEL 3, 4, so early on in the EPC, right? But it is a complex framework when having our analog processes is AWP over FEL. So it's just become, for me and the people I speak to, another structure on top of a chaos. So really, in summary, and these slides will be shared and everyone can read it, just mindful of the time, which is already total, I think. Without clean connected data, AWP planning is providing poor visibility. It is just not enough. The framework is complex. The framework is rigid. The framework is powerful, though, but it is not ready for the current data we actually have. It's missing component. But so I often jump back to digital continuity. That's different. Digital continuity is links between engineering, procurement, fabrication, and construction or assembling, but in real time. It's a tag level narrative. It is not another package narrative. So you just don't plan better, you adapt better. That's what construction needs. We need adaptation. We don't need better planning. I mean, our plans sucks because they become cost breakdown structures instead of being work breakdown structures. But that's probably for another topic, another subject. We need ways to adapt better. So to be able to recover faster, you need to be able to hand over to startup, the startup phase, clean. People could not be looking at a whole dossier, folders of drawings, and repertoires and hierarchy of delivery on USB stick to find what they're looking for. So to me, digital continuity and thread, data-centric, really. Well, we've been speaking about that for 10 years, which is just another word. It's just how we move from efficiency to resilience. Although AWP with digital continuity will become very strong, AWP will actually regain power to the production planning, to the planning command and control center. Planning is now left into building these primaveras of 30,000 raw item with predecessors and successors that are so macroscopic that there is no piloting of the project. It's just become a reporting tool. Owners and operators are requiring a breakdown structure of cost because we have a hard time transforming a project breakdown structure into a cost breakdown structure. We just do not have the right tools. My next slide is how do we all build together? And what do we build forward, right? And I want to speak about the digital asset that's actually usable for startup, commissioning, startup, mechanical completion, startup, the startup phase, critical startup phase, and operation. So it's not another stack of PDFs. It's not a hard drive of CAD files. It's not enough to have unstructured information and analog data to be able to go to the goal of digital twin. So a structured, intelligent, and contextual digital twin would link the physical asset to the functional asset. Too often, I come across digital twin software, not really twins, and misfunctioning data integration process. So you expect that, show up at startup or commissioning and operation, and you got to reload the 3D model, you got to reload all the PNID, you got to reload all the tags, you got to reload the SOPs, you got to reload the complete history of 24 months of execution of the project within how many months and with what kind of accuracy when you do it after the fact. I invite you to build a house and to get the 3D model only at the end and all the drawings only at the end and haven't built it across time. This is what we suggest we should do. We should actually get EPC digital thread, building the asset and ready for handover startup. This is really the transformation. It's going to move us from manual processes to automatic processes. It's going to move us from fragmented and disconnected information to connected information. Probably we're going to lose paper trail, paper document, PDF to XML data, JSON data, for those that are familiar with this format. Very important. Did you know that PNID documents or PNID deliverables are not only PDFs? They come from very smart softwares, Aviva PNID, Smart PNID, and some others, maybe not relevant for our industry. But they output very interesting information that are data-based, they are structured, they are useful, we can use it in many, many ways. So it all starts with the right information model, and it's from day one. If you do it later, it is too late. And my slide about AI. So I just want to give some perspective. There is about 180 FPSOs in operation as of today. There are about 30 under construction, FPSOs under construction, and about 70 to 90 planned projects in the pipeline for the next few years. And I've often heard that we have enough data, that should be enough to train the AI, look what it can do, so magical. And the reality is a bit different. It's very much different. If you take, for example, ChatGPT software with their model 4.0, pretty cool model, very good, very efficient. It uses about it was trained, sorry, on about 300 terabytes of highly curated data. I don't know if you knew, but the data is labeled. The data, we told it what to do with the data, or what it come from, or what it is for, or how important it was, and how sensitive it could be. It is not data as unstructured, completely unstructured information. Is mixed, but there is a lot of clean text, a lot of language, a lot of meaningful code, software code, a lot of code, a lot of coding is available online. A lot of history of moving from Fortran 90 to Java to web. It's impressive what's on the internet. So it's trillions of tokens on the AI language. A few token is a byte, and my estimation, I don't think I'm too wrong, but with about 50 FPSOs, we would be able to train a 4.0 model level of reasoning, of chatting and reasoning to what it is today, 50 of them. So that's actually if our PDFs were quite structured, or we spent a lot of time labeling everything, tagged PNIDs, have all the sensor logs of the operation, 3D models left and right with intelligent 3D models, not dummies, a bunch of emails and spreadsheet, because 50 years ago, if you do one FPSO per year, I mean, let's say 20 years ago, we had a lot of spreadsheets. I think we still do. So it's just not structured, and so it's harder. It's scattered. It's not built for AI to learn from, at least not yet. So if really ChatGPT 4.0 was fed a gourmet meal of data, we are offering it a warehouse full of unlabeled cans. That's why AI in EPC isn't just about having enough data. It's about making that data usable. It has to be clean. It has to be connected between each other and contextual. It's
Saber.
Yeah.
I'm gonna break it. You're telling a lot of interesting stories, and thanks for doing that. I'm a little bit conscious of time. Yep. It's 20 minutes to 4 in the Netherlands, so it's way later on your place. But I think you have shared so many things, and a clear insight on the reasoning how you would approach the efficiency in projects. I think there are people in the room that probably have some questions. Sure. Or might even disagree with some of the elements that you have said. So I think it's very good if there could be a little bit of conversation going on now. Sure. On these kind of topics. I don't want to stop you. Maybe you have one last thing that you really say. This is the summary of all.
So I'm closing in then. So last slide is really we joining the FL3DMS at USPI. I think it's a great opportunity to make sure that everyone is conscious about what's in their construction, and we're part of the handover mindset over the whole life cycle. It's still too much to say, but in fact, yeah, thank you everyone. And we have a little survey, so would love to be able to get your rating on the presentation and get to answer your questions one-on-one if you have some time next week or the following weeks. Thank you very much.
Great, thanks, Saber. Great to see all this work coming together in terms of data and using data in the right way. I see people start raising their hands. I think that is the way to do it. Please raise your hand, and I will go and facilitate this. So, Steve, please.
Maybe Anders?
You're on mute, Steve. If not, then we go to Anders.
Hi, Anders.
Thanks for a very, very good presentation. I missed a little bit of it. I had to step out, unfortunately, but I really enjoyed the presentation. I think you hit all the issues we see in reality very much on the head. And I think your proposed approach resonates very much with our thinking too. So I'm with Shell, and we've been very involved in defining the AWP process. I think Jay is on the call. He's been very involved with CII and defining that process, and also the associated data standards, which lean on the 3D model. It leans on CFIRS. And what we also see, of course, is your point about planning. Well, we want to try and get the planning reflected or tied to the 3D model, so we can visualize and simulate the path of construction before we go and construct. And then we want the planners also to be quite connected to what's actually going on, what's actual status. And as you said, we need to be able to be flexible and reschedule the work to what is available, in fact, to be done on the site. So work packages that are available, you should try and reschedule to feed the work front with those work packages. I think one of the challenges, I see with the other work we've done with CFIRS, FL3DMS, and so on, is the competences we have just in those basic standards. If you think about it, CFIRS is quite basic. It's just a standard for the asset breakdown structure and the document breakdown structure, and yet a lot of people struggle with implementing it very well. The same thing with 3D models. There's not a lot of rocket science to FL3DMS. It's just getting the structure right in the 3D model in such a way that you can build off it, right? Again, there we see very poor, in reality, we see very poor implementation sometimes. And then when I look at the AWP standard that we've developed, which underpins kind of also with CII, right? It underpins the work you're talking about as well. That's more complex because it ties the other stuff together. So you need to understand a little bit of the CFIRS standard. You need to understand a bit of the 3D modeling standard, and you need to understand planning, right? So it's tying a couple of different disciplines together, and materials management as well. And I think, typically I think the biggest obstacle is actually competences. We have the systems, we have the standards, we have the processes, but we struggle to implement them because we don't have the right competences. And that's one of the things I sort of spend a lot of time on. What should we do at industry level? Have you maybe you've thought a bit about this, and I was keen to get your thoughts on how do you drive success even when you're faced with insufficient competences, perhaps across all these different groups to implement all of this in the right way.
So it's unfortunate that the way AWP is integrated into a project execution, it's pushed down the throat of the teams that are already drowning through the amount of work, and I don't think, and I think it's also human, they don't see changes as, that's the common, virus in our day-to-day. But it is, what you say is extremely relevant. Finding the right way to implement something so wide, and the spectrum of it is so wide, that it must be it takes years. It just takes years to implement. There's no choice. The people that are actually supposed to get trained and supposed to implement the new processes on projects, they're not outside projects. That's the P&L. They are doing projects, and that's their job. And once they're finished, they can't just be a resource on the bench. they go to a next project. So I found it so hard, Anders. And as I put my hat of a software vendor and a founder, I have found ways that commercially integrating, implementing my software within a large ecosystem of software, complex ecosystem of software, legacy one, 3D one, material management one. I even have clients that are installing ERP system for the material management or the progress tracking. They're moving from Excel to, and they are not small. They are very big. So I think the competencies or could be just function of people availability. It's people wants to change at a small pace, but they're unavailable and they move and they go from a career to another career. And as soon as you have an AWP certification, you kind of promote it. And I want to raise another issue that I found and that disturbs me. And I think it's similar in the building industry, is that we unfortunately see that AWP forces companies to invest. I've heard 2% for 10%, 2% investment over CapEx project for 10% improvement in productivity. It sounds nice after a couple of years of hardship. Now, this means that you employ a new set of team, a new team comes in and disrupt how things are going on. I am sad to see that there are AWP teams. So we just move the problem. We move the problem from, in my past, planning was like that center of command. I love the Italians for that. Italians were so strong in planning. And they really control their projects. They are the people that understand the scope that changes, what the client wants, what the construction are fucking up with, and they make sense of stuff. Now planning is doing Primavera P6, and AWP teams come in and are the production planning team, are the team that knows the scope of work, that manage document revisions, and that helps everyone understanding what are the problems. And that is a problem to me. We've put more people into a problem that we haven't solved.
You.
Good. I'm going to ask Jay Moser. And I think Jay, you will introduce yourself, but I think you are a board member of the CII, correct?
Correct. Yes, we are. I'm going to sit on the board. Yes, it's correct. The board of advisors. And yeah, Saber, I won't get into too big with details here, but it's just to kind of help expand the conversation.
Yeah, we can't hear you, Jay. Jay, you got muted.
I'm sorry. Okay, Saber. Yeah, I'm not going to get into too many details here. I just wanted to kind of say one, thanks for bringing the information. I think we all, if you've been in the industry very long, all recognize the problems. Okay, there's a lot of problems you identified there that we need to solve. And I don't think there's one solution that whether that's AWP or lean or whatever the process of the day is going to do it. It's going to take a combination of best practices throughout the industry to push us differently. All I will say is that when you look at the oil and gas or energy projects in the history of our productivity, we are second from the bottom, and it's been that way for 40 years. So what are we doing wrong? We're not stupid people, all right? I think everybody can bring together a solution that supports better outcomes for owners and for EPCs. Everybody should win, right? And so I think the message you're coming out with here is look, we've got a couple of things. We've got the history, we've got the problems, we got the process, we got digital now on top of that. We got AI coming at us left and right. And how do we, get from being the old lined paper that we used to use on projects, and I've done it. I've got those green book tablets. I've still got them today. To understanding and having something that pulls all the information to one place and allows you to look at that information very quickly and have real-time progress, right? And that makes you safer, it makes you smarter, it makes you better quality. The process, in my opinion, of work packaging, regardless of what you call it, I'd say, how do you get unconstrained execution? That's the end of the day, right? 50% of this money is spent in execute. And then 40 is in procurement, right? So if you don't get it procured right, you don't get it executed right, you don't get it engineered right, you're always going to pay more the longer you go. And that was your two curves that you showed, right? So we all get on that board with that. But look, this is not Legos. This is hard work. And unfortunately, we have to have something to tie the necessary data that we need together so that we can put it into okay, maybe it's a technology. We have yet to see the true benefits of the digital aspects and applying those digital aspects to things like work packaging, for instance, okay? You mentioned CII's requirements of, hey, yeah, it's 2%. I mean, we're running a 0.5% cost, to implement. But, and do we get 10% benefit? Okay, you can argue maybe that should be 30% benefit. If we had the capability to track the KPIs and the digital data to do it correctly, the benefit is going to go up hugely. And it's not the process, right? That's just becoming digital.
That's exactly what you said. Absolutely,
right.
Jay.
Yep.
Yeah, you just said if we had the data, we do not have the data.
Well, and I agree with you, okay? But I think, I've been doing this in the industry for about 7 years, and I think it's come a long way. So for those on the call, all I wanted to do was say, check it out. Go look at what's being done with, I think it's SP19 is the special paper that was issued from the joint working group. Anders, he's got one of his members on that team. We started this work 6.5 years ago, I think, in August of 2019. And it's come a long way. We've merged that information with CFOS to help us say that, we need all data, not just construction execution data, not operate data. We need all data. So just go out and do a little bit of looking around I'm going to take the audience here and give you a challenge, because Saber, you're right. I'm not sure what your company has to offer, and I'm glad to listen and talk to you about that. But I think the problem itself needs to have a consistent solution. And if we don't do that at the industry level, then we're going to miss the boat, because we need the EPCs to make money. We need the owners to make, good assets. We need good digital twins. We need them safe. And in order to do that, we all going to have to work together. So get the data right. I think it'll all fall into place. I'll leave it at that. Thank you for the presentation.
Thank you, Jay. Yes, thank you, Jay.
Thanks, Jay. Anybody else with a question or a comment? It doesn't need to be questions. You can also have different opinions. I think that's only good. Sharpen the thinking.
There's quite a lot going on in the chat.
Yes.
It's maybe good to just see there were some, I'm not sure, specific questions in it. Let's just have a look through that as well.
Yep.
Good idea. Yeah.
Dave is asking, excellent presentation. Thank you. What solutions do you see sitting in the simulate space?
Do you see sitting in the simulation space? So if I understand the question right, yes, Dave? Dave, are you still here?
Yeah.
You want to elaborate before I answer?
Yeah, on your curve you showed there that the companies that are using the simulate, then they're going to have a better offering and a more efficient offering at the end of the day. Do you have any specific solutions that you see sitting in that simulate space?
We entirely focus on workfront simulations, the ability to know what's available to do.
So construction visualization, say in the 4D space.
Well, I would disagree with 40 space, but
Okay.
time bounded, yes, Dave, time bounded. What you see on the screen here, I haven't presented the cube on the left, but what this tried to tell everyone is that we have the data and the ability to actually know every single tag of our project, know its activity life cycle, know if it's done, know how long it takes to get done, and what would that open for work to the other things physically connected to it. And we automate that. That's the algorithm. So one would say it's a level 6, 7 planning today. Even that notion is a bit lost because it's too many lines. But it's a level of weld joint number X for spool X, and that's a BW type of weld, and that's a task. Fabricate. So this is what I describe as a task in the small cube at the bottom. Product times activity times geography. I understand where is the spool going to happen, what type of element it was, a spool, and what activities are linked to it. I hope this help.
So you're talking about your solution for the simulate phase?
Yeah. This the one
Okay.
we've built. In essence, you find everything that's ready to start at the level of weld pipe support. And I think it's a capability under advanced work packaging that will enables people to adapt rather than plan. But we have a look ahead. So sure, planning, but short-term planning. Yes, Laura.
Yeah, hi. Thanks for the presentation. It's really nice. I found the comment about linking the cost breakdown structure, linking your estimates and your model very interesting. How do you approach that currently? What's your vision on that?
So there are a lot of things, Laura, that I cannot really say because there are all the software vendors in this conference. I'd be happy to discuss with you anytime.
Yeah, will be very interesting.
We keep things connected, so it's something I do. We prototyped moving from feed to EPC is something I have an eye for. We've made many advancements, but this is not something that I've commercially productized, if I may say. But we've done a lot of things.
Follow up on that.
Sure. Thanks for the question.
So there was also another question in the chat from Paul Turner about AI. Systems are doubling in capability every 7 months. We are on an exponential trajectory. The cost of intelligence is also going to zero, disrupting knowledge workers. It seems we will eventually be able to compress 3 years of engineering into 3 weeks or less, no longer a slave to engineering information. What are your thoughts?
Here's my thoughts, Paul. My thoughts is that this would happen in a few years. It sounds very scary that you go from 3 years to 3 weeks, but this is going to happen. Intelligence is going to become a commodity, so it's going to be free. It's going to be, on demand. You're going to almost like a rental movie, pick something and get a process diagram done. So maybe we'll be renting AI agents to do things for us. But to answer the questions, I think we need something else. I could not finish the AI presentation slide, but our common limitation is computing. We'll get there. We'll get there when I think quantum computing will be ready and not just for show. It will be there once we have enough data fed into AI. Okay. The conversation about the quantity of data is very important for training models. And I think it will be ready and that will be happening once you get other kinds of model, not just large language types. There are many other types that are coming up. And I think construction, here you took a case of engineering, but I think our world is visual, is spatial. It needs physical identification, categorization. It needs understanding. So we need to label the videos. We need videos on site. We don't have videos on site. That's my thoughts, Paul.
All right, good. We have we are overrunning 2 minutes by now. So pretty well done, I would say. I would say if there is